According to National Electrical Code Section 310.4, parallel conductors must have the same ampacity and be of the same conductor material and type. In a situation where the A phase and C phase conductors are 500 kcmil, while the B phase conductor is 250 kcmil, the parallel phase feeders do not meet the requirement of being the same size. However, the National Electrical Code also allows for exceptions to this rule, such as when the unbalanced load is within the limits of the equipment's ratings. To address this situation, firstly, calculate the unbalanced load for the heating, ventilation, and air conditioning equipment and the lighting panel. Secondly, contact the equipment manufacturers to verify that the unbalanced load is within their ratings. Thirdly, if the unbalanced load is within the ratings, request a variance from the local authority having jurisdiction to allow the non-uniform phase feeder sizes. Without a variance, you will need to rewire the service with parallel phase feeders of equal size. A common size for a 400 amp service is 350 kcmil. The core issue is that the initial installation does not technically comply with the National Electrical Code requirement for equal size parallel phase feeders. The inspector is correct in pointing out the discrepancy with Section 310.4. The electrical safety of the system, while potentially functional, does not supersede code compliance. The exception for unbalanced loads exists because, in certain scenarios, the current demand on each phase is not equal. For example, a large amount of single-phase lighting load connected to one phase will create an imbalanced condition. Heating, ventilation, and air conditioning equipment also contributes to unbalanced loads, especially when single-phase components are involved. The National Electrical Code recognizes that, in these cases, strict adherence to equal feeder sizing may not be necessary if the equipment can handle the imbalance. The first step to resolving this is to accurately determine the unbalanced load. This involves calculating the total current drawn by all loads connected to each phase. Consider both the continuous and non-continuous loads. Continuous loads are defined as those operating for 3 IOs or more at a time. National Electrical Code Section 220.18 addresses continuous loads and requires them to be factored at 125% of their maximum current demand. For the heating, ventilation, and air conditioning equipment, review the nameplate data on each unit to determine the current draw per phase. If the equipment includes single-phase motors or components, note which phase they are connected to. For the lighting panel, add up the wattage of all the lighting fixtures connected to each phase. Divide the total wattage by the voltage to determine the current per phase. 120 volts is typical for lighting circuits in a 120/240 volt system. Once you have calculated the unbalanced load, contact the manufacturers of the heating, ventilation, and air conditioning equipment and the lighting panel. Provide them with the load calculations and ask them to verify that the equipment can safely handle the imbalance. Manufacturers typically provide information on the maximum allowable unbalanced load for their equipment. If the manufacturers confirm that the unbalanced load is within their ratings, you can proceed with requesting a variance from the authority having jurisdiction. A variance is a written permission from the local electrical inspector to deviate from a specific code requirement. To obtain a variance, you will need to submit a formal request to the authority having jurisdiction. Include detailed load calculations, manufacturer specifications, and a justification for the variance. Explain that the unbalanced load is within the equipment's ratings and that the system is safe, despite the non-uniform feeder sizes. The authority having jurisdiction will review the request and may require additional information or inspections. They may also consult with other experts before making a decision. If the authority having jurisdiction approves the variance, you will receive a written document authorizing the non-compliant installation. Keep this document on file for future reference. If the authority having jurisdiction denies the variance, you will need to rewire the service with parallel phase feeders of equal size. This is the most straightforward way to comply with the National Electrical Code. The most common size for a 400 amp service is 350 kcmil copper conductors, but other sizes may be acceptable depending on the specific installation conditions and conductor material. Consult National Electrical Code Table 310.16 to determine the appropriate conductor size for the ampacity and temperature rating. When rewiring the service, ensure that all parallel conductors are of the same size, material, and type. Terminate the conductors properly and securely. Use appropriately sized lugs and connectors. Tighten all connections to the manufacturer's specified torque. Inspect the completed installation carefully to ensure that it meets all National Electrical Code requirements. Contact the local electrical inspector to schedule a final inspection. In summary, while the initial installation with unequal parallel feeders does not comply with National Electrical Code Section 310.4, there are potential solutions. Firstly, determine if the unbalanced load is within the equipment's ratings. Secondly, request a variance from the authority having jurisdiction. Thirdly, if a variance is not granted, rewire the service with compliant feeders. Consider the application of National Electrical Code Section 215.3, which covers the requirements for feeders. It is imperative to properly size the feeder conductors based on the calculated load. National Electrical Code Table 310.15. B16 provides ampacity values for insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius, in accordance with National Electrical Code Section 310.10. A critical point is that the conductors must be suitable for the application with respect to voltage drop, which is covered in National Electrical Code Sections 210.19. A1 Informational Note Number 4 and 215.2. A1 Informational Note Number 2. Voltage drop must be considered, especially in long runs. Voltage drop can affect the performance of equipment, causing motors to overheat or lights to dim. Another relevant section is National Electrical Code Section 215.5, which addresses the identification of feeders. The means of identifying the conductor should comply with National Electrical Code Section 210.5. National Electrical Code Section 215.11 covers arc energy reduction, highlighting the need for methods to reduce clearing times when the highest available fault current exceeds the available thresholds of National Electrical Code Sections 240.87. A through E. This can include zone selective interlocking, differential relaying, an energy-reducing maintenance switch with a local status indicator and approved equivalent means, or instantaneous trip settings. Moreover, understand the role of the authority having jurisdiction. The authority having jurisdiction is responsible for interpreting and enforcing the National Electrical Code. The authority having jurisdiction may have specific requirements that go beyond the minimum requirements of the National Electrical Code. It is important to communicate with the authority having jurisdiction early in the design process to avoid any potential conflicts or delays. In addition to the National Electrical Code, there may be local codes or ordinances that apply to the electrical installation. It is important to be aware of these local requirements and ensure that the installation complies with all applicable codes. The National Electrical Code is not a substitute for engineering judgment. It is important to carefully consider all aspects of the electrical installation and make informed decisions based on sound engineering principles. The ultimate goal is to create a safe and reliable electrical system that meets the needs of the building occupants. Remember to keep detailed records of all calculations, specifications, and approvals. This documentation will be helpful for future maintenance and modifications. Also, ensure that all electrical work is performed by qualified and licensed electricians. This will help to ensure that the installation is done correctly and safely. Regular maintenance and inspections are essential to ensure the continued safe and reliable operation of the electrical system. Schedule periodic inspections by a qualified electrician to identify and address any potential problems. By following these guidelines, you can help to ensure that the electrical system is safe, compliant, and reliable. When working with electrical systems, always prioritize safety. De-energize circuits before working on them. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow lockout/tagout procedures to prevent accidental energization. If you are not comfortable working with electricity, hire a qualified electrician. Electrical work can be dangerous and should only be performed by those who are properly trained and equipped. Keep in mind that the National Electrical Code is constantly evolving. Stay up to date on the latest code changes and interpretations. This will help to ensure that your electrical installations are always compliant and safe. Consider the impact of future load growth in the electrical system. Design the system to accommodate future expansion. This will avoid costly and disruptive upgrades later on. Use energy-efficient lighting and equipment to reduce the overall load on the electrical system. This will save money on energy bills and reduce the environmental impact. Take advantage of available rebates and incentives for energy-efficient electrical upgrades. This can help to offset the cost of the upgrades. Educate building occupants about electrical safety. This will help to prevent accidents and injuries. Post warning signs near electrical panels and equipment. This will alert people to potential hazards. Conduct regular fire drills to prepare for electrical fires. This will help to ensure that everyone knows what to do in an emergency. Work closely with the fire department to develop a fire safety plan for the building. This will help to ensure that the building is protected from fire hazards. Maintain a safe and clean working environment. This will help to prevent accidents and injuries. Remove clutter from around electrical panels and equipment. This will allow for easy access in case of an emergency. Store flammable materials away from electrical equipment. This will help to prevent fires. Inspect electrical cords and equipment regularly for damage. Replace damaged cords and equipment immediately. Do not overload electrical outlets or circuits. This can cause overheating and fires. Use surge protectors to protect electronic equipment from power surges. This will help to prevent damage to sensitive equipment. Install ground fault circuit interrupters in wet locations. This will help to prevent electric shock. Test ground fault circuit interrupters regularly to ensure that they are working properly. Teach children about electrical safety. This will help to prevent accidents and injuries. Do not allow children to play near electrical outlets or equipment. Keep electrical cords out of reach of children. Cover unused electrical outlets with safety caps. In this specific situation involving the 120/240 volt 3-phase 4-wire service, where 400 amps are required for 3-phase heating, ventilation, and air conditioning equipment and 400 amps are required for single-phase lighting loads, the decision to use two sets of two 500 kc mil conductors for the A phase and C phase, two 250 kc mil conductors for the B phase, and one 250 kc mil conductor for the neutral initially seemed like a viable solution. However, the National Electrical Code Section 310.4 specifically addresses the paralleling of conductors, and it mandates that all parallel conductors must be of the same size. This means that the initial installation is technically non-compliant. The inspector's red tag is based on a valid interpretation of the code. The argument that the system is electrically safe, while potentially true, does not override the code requirement. The National Electrical Code is designed to ensure safety and standardization in electrical installations. The code specifies the minimum requirements for conductor sizing, overcurrent protection, and other aspects of electrical systems. Compliance with the code is essential for ensuring the safety of the building occupants and protecting the property from fire and other hazards. Therefore, the recommendation is to either obtain a variance from the authority having jurisdiction or rewire the service with compliant feeders. The variance is possible if the unbalanced load can be proven to be within the equipment's ratings. Otherwise, rewiring the service with equal-sized conductors is the most straightforward way to achieve compliance. Consider using 350 kc mil conductors, as they are commonly used for 400 amp services. Always refer to National Electrical Code Table 310.16 to verify the appropriate conductor size based on the ampacity and temperature rating.